We want to complete the table below. We're told Z is A cis alpha and W is B cis beta. We want to state the modulus, argument and the transformation for each of the following. So let's look at Z bar. So if we think about the conjugate of Z, this is the real axis just here. Let's say that Z is here and this angle is alpha. Then we know that the conjugate is a reflection in the real axis. So it will have the same length because remember it's only the sign of the imaginary part that changes. So it's going to have a modulus of A. The argument would be negative alpha and the transformation is a reflection in the real axis. So the next one we want to look at is IZ. Okay, so we know that I is cis pi by 2. So if we multiply, doing IZ, we're going to get A cis alpha plus pi by 2. So if this was the alpha, it's going to rotate around like so. So the modulus will be A. The argument will be alpha plus pi by 2. And it's going to be a rotation pi by 2 radians anti-clockwise. Okay, the next one is Z to the negative 1, or if you like, 1 over Z, which is cis 0 over A cis alpha. So that's going to be 1 over A cis negative alpha. So what we have there, if we say this was our Z, it's going to be down here. The modulus will be 1 over A. The argument would be negative alpha. And it's going to be a reflection in the real axis and also a scale factor of 1 over A squared, which would take it from having a modulus of A to a modulus of 1 over A as it has. So the next one we have is ZW, and ZW, if this is Z and this is W, is going to be AB cis alpha plus beta, and so it's going to be AB, and the argument would be alpha plus beta, and so it is going to have scale factor of B, and it's going to be a rotation of beta anti-clockwise. So if beta is negative, it would go clockwise. And then finally here we have Z divided by W. So we know that that is going to be A over B cis alpha take beta. So the modulus would be A over B. Argument alpha minus beta. The scale factor is 1 over B, and it will be a rotation of beta, in this case, clockwise.